Today our topic is storage class in C. Now we learn properties of a variable. Mainly there are three properties of a variable. First is name of the variable, means say we declare any variable, name of that variable is I. Size of memory block, say if the variable is an integer variable, it will allocate 4 bytes in memory. And type of contents, because it is integer variable, it holds integer value. So it holds integer value, that is the type of content, it is integer. There are some other properties of variables. First is default value, means if we declare any variable and if we not initialize that variable, then what will be the initial value of the variable if the initial value is not assigned, that is the default value. Second is storage, means where the variable would be stored. There are basically two kinds of location in a computer where such a value may be kept. First is memory and CPU register. So storage means where the variable would be stored, whether it is stored in memory or stored in CPU register. Scope, in which function the value of the variable would be available and in which function it will not be available. Life, how long would the variable exist? So what is storage class? Storage class means storage class are used to describe these features of a variable or function. Means what? These features basically include the scope, visibility and lifetime, which help us to trace the existence of a particular variable during the runtime of a program. In C, there are four storage classes. First is automatic storage class, second is register storage class, static storage class and external storage class. The features are given below. You have to remember these features. Pause this video, try to learn this feature and remember these features. First is automatic storage class. In case of automatic storage class, the keyword is auto and default value means it is an unpredictable value which is often called a garbage value. Storage is it is in memory, it's stored in memory. Scope is it is local to the block in which the variable is defined. And life is till the control remains within the block in which the variable is defined. Then we will learn register storage class. In case of register storage class, keyword is register. Default value is also garbage value. Storage is it is stored in CPU register. Scope is it is also same local to the block in which the variable is defined. And life is also same till the control remains within the block in which the variable is defined. Then static storage class. In case of static storage class, keyword is static. Default initial value is always 0 here. Remember, you have to remember this point that the default initial value of static variable is 0. Storage is its stored is in memory, that is in RAM, and scope is same, means local to the block in which the variable is defined, and lifetime is value of the variable persists between different function calls. I repeat, value of the variable persists between different function call. And finally, external storage class, keyword is extern and the default initial value is 0. Storage is also in memory, that is in RAM. Scope is its scope is global. Remember this thing, its scope is global, and life is as long as the program's execution does not come to an end. So these are the basic features of storage classes. Now we learn automatic storage class. See, in case of automatic storage class, keyword is auto, default value is garbage, that is it is an unpredictable value. Storage is in memory or RAM. Scope is it is local to the block in which the variable is defined, and life is till the control remains within the block in which the variable is defined. So see this program, how an automatic storage class variable is declared. See this auto, first you have to write auto, then int ij. So If the variable is not initialized, it contains garbage value. See, these variables are not initialized, so ij contains garbage value. When you run this program, you may get different values since garbage values could be absolutely any values. So always make it a point that you initialize the automatic variables properly. Otherwise, you are likely to get unexpected result. So, and also note that the keyword for this storage class is auto, not automatic. So see, when we run the program, it is garbage value. Now we discuss another example of automatic storage class. We already learned that the scope of automatic storage class variable is local to the block in which the variable is defined. See this example. Here the compiler treats the three i's as totally different variables since they are defined in different blocks. Once the control comes out of the innermost block, means this block, this bracket, within this bracket block, the variables of I with the value 3 is lost. So it prints, first it prints value printf I means it prints 3, then it comes out from the block. So the variable I with value 3 is lost now. Next, then the I in the second printf means this printf, this block, from this bracket to opening bracket, closing bracket, this printf. Then the I in the second printf refers to I with value 2. So then 2 will get printed. Then finally, when the controls comes out of the next block, the third printf refers to the I with the value 1. So what will be the output? It is 3, 2, 1. So we already learned that in case of automatic storage class variable, scope is limited to the block in which it is declared. So tell me, what is the output of this program? Think for 5 seconds. See here, when the control comes out of this innermost block of the variable x with the value 2 is lost. So first time it prints 5, then it prints 2, and again when the control comes out from the block, again it prints 5. So when we run the program, see the output, it is 5, 2 and 5. Now we learn register storage class. The features of a variable defined to be of register storage class are: here the keyword is register, storage is CPU registers, default initial value is garbage value, scope is local to the block in which the variable is defined, and life is till the control remains within the block in which the variable is defined. A value stored in a CPU register can always be accessed faster than the one which is stored in memory. So, if a variable is used at many places in a program, it is better to declare its storage class as register. If you use any variable in many places in your program, then you can define that variable under register storage class. A good example of frequently used variable are loop counters. See this program. So you have to define in this way. See here, first you have to write keyword register, then int I. So this I, we here we use this I frequently. So we define in this way. Now when you run the program, you see the output as usual. But we cannot say for sure that the value of I would be stored in a CPU register. Why so? Because the number of CPU registers are limited and they may be busy doing some other task. So we cannot sure that the value of I would be stored in a CPU register. In such an event, the variable works as if its storage is auto. See another example of register storage class. See here, I declare one register storage class variable register int x equals to 4. See, here x is used at many places in a program, in this program. So we have to fetch x from RAM to CPU numbers of times, and this process is very much time consuming. To save time, we have to keep x in CPU. CPU means data register. So it is better to declare its storage class as register. Now we learn static storage class. The features of a variable defined to have a static storage class are: first is the keyword is static, default value is 0, storage is in memory, that is in RAM, scope is local to the block in which the variable is defined, and life is value of the variable persists between different function calls. I repeat, value of the variable persists between different function calls. See, to understand the difference between the automatic and static storage class, first we learn one example. See this example. In this example, there are two functions. One is main, another is increment. The function increments gets called from main thrice. Each time it increments the value of I and prints it. See here, each time it increments the value and prints the value. So first I is 1, so print I and then increase the value of I. Now see, when the variable I is auto, each time increment is called, it is reinitialized to 1. Means when the function terminates, when this function terminates, I vanishes and its new value of 2 is lost, because the scope of I is local to this function. So when the function terminates, I vanishes and its new value of 2 is lost. So each time when I call this increment function, no matter how many times we call increment, I is always initialized by 1. So when we want to get the output, it is 3 times it is called. So it gives the value 1, 1 and 1. See, output is 1, 1 and 1. Now compare the same program in case of static variable. See here, I write static int I equals to 1. See, first, like auto variables, static variables are also local to the block in which they are declared. So this variable I is also local to this block in which it is declared. But the difference is that the static variable don't disappear when the function is no longer active. Means what? Their value persists. If the control comes back to the same function, their values persist. So the static variable have the same values they had last time around. So if I is static, it is initialized to 1, I equals to 1 only once. It is never initialized again because its value persists. During the first call to increment, first call of increment, this function, I is incremented to 2. So first print I is 1, then I is incremented, so it becomes 2. Because I is static, these value persists. So the last value of I is 2 and this value persists. The next time increment is called, this line, next time increment is called, I is not reinitialized. On the contrary, its old value 2 is still available. So what is the value of I now? In the second call, it is 2 now. So 2 becomes 3. The current value of I is 2 gets printed. So first 2 printed and then I equals to I plus 1. So I value of I becomes 3. When increment is called the third time, this time, last one, third time, the current value of I, 3 printed and once again I is incremented. Okay. So what will be the output? Output is 1, 2, 3. So in short, we can say that if the storage class is static, then the statement static int I equals to 1, this line, is executed only once, irrespective of how many times the same function is called. So, this is the difference between auto and static storage class variable. The value persists between different function calls. So, tell me what is the output of this program? See here, from main I call the function f1 two times, and in this function I declare one variable I of static type, static int I, and I increase the value of I and print the value. So, first time, what is the value of I? The default value of any static variable is 0. We already learned this thing. So, value of I, default value is 0. So, when I write I plus plus I becomes 1, it prints 1. Because the value of this variable persists between different function calls. So, second time when we call f1, the last value of I was 1. So, it becomes 2. So, what will be the output? See the code. See here. So, no initialization is done here. It automatically takes 0, and second time it will print 2. So, when we run this program, see, it is 1 and 2. So, first time it becomes 1, print 1. Second time when we call f1 again, it last value of I was 1. So, it becomes 2, it prints 2. And the default value of any static integer variable is 0. One thing you have to remember, avoid using static variables unless you really need them, because their values are kept in memory when the variables are not active, which means they take up space in memory that could be otherwise be used by other variables. Our next storage class is external storage class. Keyword is extern, default value is 0, storage is memory or in RAM, scope is global, and life is as long as the program's execution does not come to an end. So here, see, I declare one extern storage class variable. First you have to write extern, then int x. So it is not local variable, it is global variable. Any function can access this variable. So I can access this variable x from this function. So I can write x plus plus here. See here, if you declare any variable extern int x, again outside of this function you have to declare it again. This is the syntax. So external variable scope is global, not local. External variables are declared outside all functions, yet are available to all functions that care to use them. So see this code carefully. When we run the program, we get the output. First time, because default value of extern variable is 0. So first time it prints 0, then we call f1 function. It is incremented in this function. What is the value of x now? It is 1. Now again when I want to print, because it is global variable, it again prints 1. Okay. Now use of extern is optional as long as we declare it outside. So you can omit this extern variable, means you can omit this line and you can declare this variable int x outside the main, means make it global variable, as long as we declare it outside, and above that functions in the same source code file. So in this way you can also write external variable. So use of extern is optional here. So again when we run the program, we get the same output. See, we get the same output. See this example, then it will be more clear. First see, here x and y both are global variables. Since both of them have been defined outside all the functions, both are enjoy external storage class. See, it is defined outside the function, it is also defined outside the function. But the difference between the following. First one is, extern int y and int y equals to 31. See here the first statement extern int y. This statement is called declaration, whereas the second statement is called definition. So this statement declaration, this statement definition. When I declare a variable, no space is reserved for it. If we just write extern int y, no space is reserved for it. But when we define it, space gets reserved for it in memory. So when we declare, no space is reserved. When we define, space gets reserved for it in memory. We had to declare y, this y, since it is being used in printf before its definition encountered. Okay, so you have to declare y here because we are using it in printf. There was no need to declare x, no need to declare x, since its definition is done before its uses. Definition is already done. Also remember that a variable can be declared several times but can be defined only once. Here we define and here we declare. So what will be the output? X it is 21 and y it is 31. So it is 21 and 31. Now tell me, what is the output of this program? See here. Here x is defined at two places, once inside the main and outside the main. When the control reaches this printf in main, this printf within main, which x gets printed? In this case, whenever such a conflict arises, always remember that local variable gets preference. So over the global variable. So always local variable gets preference. Which one is the local? This x equals to 20. So 20 gets printed. After that, when display is called, after that first prints 20, then when display is called, there is no conflict because this x is local. So from display function can't access this x. So display function can't access this global x. So it will print 10. So what will be the output? It is 2010. So it is 2010. We can make a few ground rules for usage of different storage class in different programming situations with a view to economize the memory space consumed by the variables and improve the speed of execution of the program. So the rules are: use static storage class only if you want the value of a variable to persist between different function calls. A typical application of this storage class is recursive functions. Use register storage class for only those variables which are being used very often in a program. Reason is there are very few CPU registers at our disposals and many of them might be busy doing something else. Make careful utilization of the scarce resources. A typical application of a register storage class is loop counters, which get used a number of times in a program. Use external storage class for only those variables which are being used by almost all the functions in the program. This would avoid unnecessary passing of these variables as arguments when making a function call. Declaring all the variables as external would amount to a lot of wastage of memory space because these variables remain active throughout the life of the program. And finally, if you don't have any of these express needs mentioned already, then use the auto storage class. In fact, most of the times we end up using the auto variables because often it so happens that once we have used the variables in a function, we don't mind losing them. So these are your homework. Try to solve this problem. Pause this video, try to solve this problem and answer me in the comment section what is the output of this program. Pause this video, try to solve this problem and answer me in the comment section what is the output of this program. Pause this video, try to solve this problem and answer me in the comment section what is the output of this program. I am waiting for your reply. For getting more and more updates, please subscribe my channel. That's all for today. Thank you.